Welcome to Algebra 1, Lesson 30 with Miss Barrett. Per usual, let's look at our last lesson's practice answers, okay? So I'm not going to go over every answer. I just want to go over a few of the more difficult answers, problems, so that I can make sure that you understand what to do in these cases. So it says solve each system of equations. So remember, we're dealing with nonlinear system of equations. So we have one equation that is a quadratic equation and one equation that is linear. Okay, so if you look at, let's look at number 3. Oh, I'm sorry, number 4. I'm sorry. Let's look at number 4. So here we had the quadratic y equals x squared minus 6x plus 8, and then what would be our linear 2y plus x equals 4. Now remember, the first step is to always make sure both of your equations are in y equals form. So that means that this 2y plus x equals 4 has to be changed into y equals mx plus b form because it's linear. So that means we got to get the y by itself. So I'm going to get this y by itself. First step is to subtract x on both sides, right? You can't get rid of that 2 first because the 2 is connected to the y. You have to divide it. You have to cut it. Okay, so let's start with the positive x. So I'm going to subtract x on both sides. These two x's cancel out. I'm left with 2y equals negative x plus 4, right? You cannot combine those two. They're not like terms, so it's negative x plus 4. Now, in order to get the 2 and the y separated, I'm going to divide them, like cut them. So we're going to draw this line that represents the cut, and I'm going to divide by 2. Now, 2y divided by 2 is just y. And then when I divide everything on the right side, I end up getting negative x divided by 2, which is like saying negative 1/2 x, right? Because there's an invisible 1 here. And then 4 divided by 2, which is positive 2. Or if the fractions mess you up a little bit, you can just write y equals negative 0.5. 1/2 and 0.5 are the same. Just one is a decimal, one is a fraction, plus 2. So I'm going to use this one in this example, the one with the decimal. So now, once you have both of them in y equals form, okay, you're going to make them equal to each other. So I have x squared minus 6x plus 8 equals negative 0.5x plus 2. Now I'm going to move everything to the same side. So here my a value is 1, so I'm going to move everything to the right. To the left. So this negative 0.5x plus 2 is I'm going to use my inverse operations or my opposite operations. So since it was negative, now it's positive 0.50x. And then since it was positive 2, it's now negative 2. And I do that on the left side as well. They cancel out on the right side. I'm left with 0. And then negative 6x plus 0.5x is negative 5.5x. And then 8 minus 2 is 6. So now my resulting quadratic is x squared minus 5.50x plus 6 equals 0. Now, once you get your quadratic, okay, that represents the combination of these two functions, now you can use any method of factoring that you want to in order to factor it. I could have used a different method to factor this, but I decided to use the quadratic formula because it always works. If you put in the numbers correctly and you do your math correctly, it will always work. Now, I want to show you over here that I could have done the method where I find the factors of C that add to make B, but that would be more difficult. Actually, I'm not going to do that because that would be more difficult because you have a decimal here. Okay, it's possible, but it makes it more difficult because you have a decimal here. So I would suggest that if you want to use the other factoring methods, fine. But the quadratic formula always works if you put in the numbers correctly and if you do your calculations correctly. So I have x equals negative b plus or minus square root of b squared minus 4 times a times c, all divided by 2a. Okay, my a was 1, my b was negative 5.5, and my c was 6. So I plugged it in, and I got what you see here. Now, I had to simplify the radical, and I got the square root of 30.25 minus 24, which becomes the square root of 6.25. Okay, and then remember that that negative 1, invisible 1 times negative 5.5 is positive 5.5 because two negatives make a positive. Okay, so this is what I got when I simplified those two. And the denominator is 2 times 1, which is 2. Now, you have to figure out, so I did my calculations and I figured out that the square root of 6.25, so 6.25 is a perfect square. So then the square root of 6.25 is going to be 2.5. So now I have 5.50 plus 2.5 divided by 2. And then I have 5.50 minus 2.5 divided by 2. Because remember, when you're dealing with quadratics, you're going to have two answers usually. Two solutions. So now when I do my math for my two solutions, I get x equals 4 and x equals 1.5. And this is only done by putting it in my calculator. Now, once you find your x values, then you plug in your x values into your linear function, which was y equals negative 0.50 plus 2, 0.50x plus 2. You plug in your 4, which is our first x, in there, and I got out 0. Then I plug in my 1.5 in there, and I got out 1.25. That means that my solutions are the points 0 and 1.25, or sorry, 1.5, 1.25. And I wrote them up here. Okay, now let's review. For today, our notes is just a review of both of the methods. Okay, so this is lesson 30. So our important formulas are x equals negative b divided by 2a, and then x equals negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. Okay, that's your quadratic formula and your axis symmetry formula. So for number 1, we have y equals x squared minus 6x plus 3, and y equals negative 2x plus 3. Okay, so your first step when you're graphing is always to identify your axis of symmetry, which is basically your x value of your vertex. So we're going to look at our quadratic, and I'm going to identify a is 1, b is negative 6, and c as 3. And I'm going to plug in my b and my a into my axis symmetry formula. So x equals negative 6. So remember, the negative is part of the formula. B can be negative. So if it's negative, b is negative, then it's going to be negative times a negative. All divided by 2 times a, which is 1. 2 times 1. Okay, that becomes positive 6 divided by 2, which is 3. So this is our x value of our vertex. So we're going to put that 3 right here in the middle. Right here in the middle. And we're going to pick 2 points that are less than 3, equally less than 3. So let's do 2 and 1. And then we're going to pick 2 points that are also more than 3. So since 2 is 1 less than 3, we're going to do 4 because 4 is 1 more than 3, and 5. Okay. All right, now, when we do that, now that we have our x values, now we have to plug in each x value into each of our equations. So, for example, negative 2 times 1, plug in 1, is negative 2 plus 3 is 1. Y equals negative 2 times 2, which is negative 4, plus 3, which is negative 1. Y equals negative 2 times 3, which is negative 6, plus 3, which is negative 3. And you continue until you fill this out. Now, with your quadratic function, you do the same thing. Here, I would have 1 squared, because I just plugged in 1 for x, 1 squared, which is 1, minus 6 times 1, which is negative 6. So that's 1 minus 6, which is negative 5, plus 3 becomes negative 2. And again, guys, you could just put this in your calculator, the trusty, dusty calculator. So for the first one, I have, for the y equals, I would just put negative 2. Let's do number 4. Negative 2 times 4 plus 3. That's going to equal -5. Okay. For the quadratic, let's do our x value of 2. It's going to be 2 squared minus 6 times 2 plus 3. And that's going to give us -5. Okay. So I went ahead and I filled out our chart for us, our table of values. So basically, remember that all we did was we plugged our x values into these equations to get our y values. Now, after you get your table filled out, we have to graph it. So the points are for the linears 1, 1. So these count by this x-axis and this y-axis count by ones. So 1, 1 will be here. 2, -1. 2, -1. 3, -3. 4, -5. And 5, -7. Okay, and I'm then gonna connect my dots, my points. Again, it should be more accurate if you use your ruler. And then now I have to do the same with my quadratic. So my x was 1, my y was -2. 1 is here, -2. 2, -5. 3, -6. 4, -5. And then 5, -2. And I'm going to use a different color to connect those. So it's going to look something like this. Okay. So as we can see here, where they connect is where the solutions are. So that's the solution of 4, 1, 2, 3, actually 3, no, 4, I'm sorry, 4, -5, and here, this should actually be, it should be right here, guys. And here at the point 0, 3. So the solutions are 0, 3, and 4, -5. Okay. We're going to do the same thing again with the next one, the same steps. Step 1, I have y equals 2x squared minus x plus 1. And then y equals 4x plus 4. First thing I did was I identified my a, b, and c. A is 2, b is -1, c is 1. Plug that into my axis symmetry formula. It gave me -1 times -1 divided by 2 times 2, which is +1/4, or in decimal form is 0.25. If the fractions bother you, put it in decimal form. Now, once you find your axis of symmetry, you can now plug that into the middle of your x values, and then you're gonna find, you're gonna plug in 2 x values that are greater than 0.25 and 2 x values that are less than 0.25, but they have to be equal distance, greater and less than. Okay? Okay? So once I did that, I plugged those x values into the linear and the quadratic, and this is what I got out. This is what I got out now. Remember, you can always, if you have a graphing calculator, you can always put the functions into your y equals 4x plus 4 and 2x squared minus x plus 1. Then make sure your window, you go to second window and it says ask for your independent variable, which means you can put in whatever x values you want. Then you go to second graph, which will give you the table. And we chose these x values, therefore I plugged in those x values in the calculator and it gave me out my y values and for both of my functions, my equations. This is linear, this is quadratic. Okay. All right, once you have those points, then you graph them. Now this graph in particular, you can go ahead and pause the video and so you can fill out your table and your graph. This graph in particular went off of the grid. Sorry about that. But when you graph it anyway, you'll see that the two intersecting points are the points -0.5 and 2 and the points 3, 16. You can also find that in your calculator, okay, by going to graph, right? You can see where they don't mind these. You can see where they intersect, and you go to second calc or second trace. And then number 5 says intersect. Remember that you have to get close to the intersection. You don't have to get on it. You just get close to it and press enter 3 times. And it tells you what the intersection is for one of the points where they intersect. And you have to do the same thing for the other. Okay. All right, now that's graphing. Now let's look at and remember out how to solve these nonlinear systems algebraically. So if I have a system -4x plus y equals x squared minus 2 and y equals 2x minus 2. Now remember, when you're solving using mathematics, you have to make both of the equations in y equals form. This quadratic equation is not in y equals form, so we have to change it. That's step 1. So, which means that since this x squared term is already positive, we want to keep it positive. So we're not going to move this to the left side because that would make it negative. We're going to keep it over here. We're going to move everything to the left side over to the right side. So I'm going to add 4x to move it to the right side, and I'm going to subtract y. I'm sorry. Oh, I'm just going to keep y there. So I'm just going to add 4x on the to the right side because I want y to be by itself, right? So that cancels out on the left side, and I'm going to add 4x on the right side. Now, if you see, 4x does not have a like term. There's nothing I can combine it with. I can't combine it with x squared because x squared and 4x is not the same. And I cannot combine it with the 2 because it's not the same. So that leaves me with y equals x squared. I'm going to write it in standard form plus 4x minus 2. Now my quadratic is in standard form. Now I can make those two equal to each other, okay? This is all step 1. I put both of them in the y equals. Now I can make them equal to each other. So that's going to give me x squared minus 4x minus 2 equals 2x minus 2. Okay. Once you make them equal to each other, okay. Once you make them equal to each other, now you can move everything to whichever side is going to keep this a term a positive 1. So moving everything to the left side will keep this a term a positive 1, right? Because if I move this to the right side, it becomes negative. So I'm going to take this 2x minus 2 and I'm going to do the inverse operation or the opposite operation. So this is positive 2x becomes negative 2x. This is negative 2 becomes positive 2. So it's now negative 2x plus 2. What I do on the right side, I must do on the left. Becomes negative 2x plus 2. These cancel out. That was the whole point. You get 0. Over here on the left side, you get x squared negative 4x minus 2x is negative 6x. And then negative 2 plus 2 is 0. I'm not going to write the 0. I'm not going to write the 0. Okay, you don't need the 0. So now I have x squared minus 6x equals 0. That was my step 2. Now I take my x squared minus 6x equals 0, and I'm going to factor it. That's step 3. So I'm going to factor x squared minus 6x equals 0. Now this is an easy factoring problem because all I need to do is take out the GCF. And the GCF here is x. Right? They both at least have one x. So I'm going to divide both of them by x. And I get x times x minus 6 equals 0. Because x squared divided by x is x. X. And then negative 6x divided by x is negative 6. Now here I have x equals 0. So remember, anything with an x, I have to separate them and make them both equal to 0. So here I have x equals 0, and I have x minus 6 equals 0, which becomes x equals 0. So I would add 6 to both sides. So now x equals 6. So these are my x values. My step 4 is to now take those x values and plug it into the linear function. Plug it into the linear one, guys. It's just easier. Like if you want to plug it into that one, sure. Okay, but who wants to make life harder? So now I'm going to take this 0 and I'm going to plug it in. Y equals 2 times 0 plus, minus 2 equals 2 times 0 is 0, minus 2 is negative 2. And then plug in that 6, y equals 2 times 6 minus 2, which is 2 times 6 is 12, minus 2 is 10. So now that means my solutions are the point 0, negative 2, and the point 6, 10. Okay? So 0, negative 2, and 6, 10. And those are my answers. 4 steps. Okay, so number 4. So I went ahead and filled out number 4 for you so that we can make sure that we're not going over too much time on this. So we have the quadratic y equals x squared minus 4, and we have y equals 2x minus 1. Okay, they're both in y equals form, so we do not have to do that step. But the rest of step 1 says make them equal to each other. So it's x squared minus 4 equals 2x plus 1. I'm sorry, 2x minus 1. Now, I have to combine like terms or move everything from whichever side is going to keep this a term, since a is 1 here, keep this a term as 1. So that means I'm going to move everything from the right side to the left side by doing inverse operation. So instead of having 2x minus 1, I have negative 2x plus 1, and I do that on both sides. And that gives me x squared minus 2x minus 3 equals 0. Now this quadratic is what we're going to use to factor to solve for our x values. Now I could have used the quadratic formula. It always works. But I decided to use our good old other factoring method. I identified A, B, and C, and I found the factors of C that add to make B. So the factors of negative 3 are negative 1 and 3 and 1 and negative 3. Which set adds to make negative 2? That'll be 1 times negative 3, which is negative 3. But 1 plus negative 3 is negative 2. So I'll write them out as factors. X plus 1 times x minus 3 equals 0. Make both of those factors equal to 0 and solve for x. So when I do x plus 1 equals 0, I'll solve for x. X equals negative 1. X minus 3 equals 0. Solve for x. X equals negative 3. X equals positive 3. Now I take those x values and I plug it into my linear equation. Y equals 2 times negative 1 minus 1 equals negative 3. And then 2 times 3 minus 1 equals 5. So I have my x values and my y values. So So that means that the intersections or the solutions to the system are -1, -3, and 3, 5. Okay, now for your quiz review, it's going to look very similar to this practice we just did. Okay, very similar. All you need to do is follow the videos and the practice we've done. We've done practice on each method and also a practice on both methods. And it's going to be 4 problems. Your quiz will look much like these, of course, with different problems. Hope everyone has a lovely day. Bye.